Hello and welcome to Alpha Omega General Training videos. We will delve into porous medium modeling using Ansys Fluent in this tutorial. Ansys Fluent is a computational fluid dynamics tool that offers advanced porosity modeling capabilities. This tutorial is designed to help students, researchers, and engineers improve their expertise in this area. Let's get started on exploring the fascinating world of porous media modeling. In Ansys Fluent, the porous medium model is a powerful tool that allows you to simulate flow through a porous material. These materials are often used in engineering and scientific applications such as filters, catalysts, and heat exchangers. The model employs the concept of a porous zone in which the volume is occupied by porous material. User-specified material porosity and directional loss coefficients define this. Fluent solves the standard fluid flow equations throughout the porous medium with a source term to account for the pressure drop and momentum change due to the porous material. The source term is defined based on the Ergon equation or user-defined function. The porous medium model in Fluent provides an efficient way to simulate the complex physics of flow through porous materials, capturing the effects of porosity and permeability on the flow. In the oil and gas industry, porous medium play a fundamental role in reservoir engineering and enhanced oil recovery operations. The porous medium, usually a rock formation, serves as a storage and conduit for hydrocarbons. It is characterized by its porosity and permeability, which determine the storage capacity and the ease of fluid flow, respectively. Understanding these properties is vital for predicting reservoir behavior and optimizing extraction processes. Moreover, in EOR, porous medium are often subjected to various treatments such as water flooding, gas injection, or chemical flooding to improve oil displacement. The interplay between the injected fluid and the porous medium significantly influences the efficiency of these recovery techniques. Hence, a thorough knowledge of the porous medium and its interaction with fluids is crucial for maximizing hydrocarbon recovery and ensuring the economic viability of oil and gas operations. In the automotive industry, porous materials play a crucial role in various applications, contributing to the efficiency, safety, and environmental sustainability of vehicles. One of the most significant applications is in the design of catalytic converters, where porous media facilitate the conversion of harmful exhaust gases into less harmful substances. The porous structure provides a high surface area for the catalytic reactions, enhancing the converter's efficiency. Additionally, porous materials are utilized in filtration systems such as air and oil filters where they trap and remove contaminants to ensure optimal engine performance. Noise reduction is another application where porous materials are used in mufflers and sound absorbing panels to damage engine and road noise, enhancing the comfort of vehicle occupants. Furthermore, porous media are employed in advanced battery technologies for electric vehicles, where they serve as electrolyte reservoirs in the battery cell, promoting efficient ion transport and improving battery performance. Thus, porous materials are integral to the automotive industry, underpinning various applications that enhance vehicle performance, safety, and environmental sustainability. In the realm of environmental engineering, the application of porous media plays a pivotal role in numerous areas. It is extensively utilized in groundwater flow modeling, pollutant transport and remediation, soil mechanics, and waste disposal, to name a few. The fundamental principle lies in understanding the fluid flow through porous media, which governs the transport of contaminants through the soil and into the groundwater. This knowledge is crucial in designing and implementing remediation strategies for contaminated sites. Additionally, porous media is also integral to the design of landfills and waste disposal sites, where it aids in the containment and management of leachate. The understanding of heat and mass transfer in porous media also finds applications in geothermal energy production. Thus, porous media, with its wide area of applications, significantly contributes to the advancements in environmental engineering. Ansys Fluent is an advanced computational fluid dynamics software that allows users to model flow, turbulence, heat transfer, and reactions for industrial applications. One of its unique features is the ability to simulate the behavior of porous media. Below are some capabilities of porous medium in ANSYS Fluent. Porosity and permeability modeling. ANSYS Fluent allows users to define the porosity and the permeability of the porous medium. Porosity is the fraction of the total volume that is not occupied by the solid matrix. Permeability, on the other hand, is a measure of the ability of a porous material to allow fluids to pass through it. ANSYS Fluent uses these two parameters to simulate the flow through the porous medium. Internal and viscous resistance. The software provides the ability to model both inertial and viscous resistance. Inertial resistance is the resistance to the change of velocity of the fluid, while viscous resistance is the resistance to the fluid's flow due to its viscosity. These two resistances are essential in accurately predicting the behavior of the fluid in the porous medium. Heat transfer. ANSYS Fluent can simulate the heat transfer in porous media. This includes conduction, the transfer of heat through the solid matrix, and convection, the transfer of heat by the movement of the fluid. This is particularly useful in applications where the temperature distribution in the porous medium is of interest. Turbulence modeling. The software is capable of modeling turbulence in porous media. Turbulence is the chaotic movement of the fluid, and it significantly affects the flow and heat transfer in the porous medium. Ansys Fluent uses various turbulence models such as the K epsilon and K omega models to simulate turbulence. Reactions and species transport. Ansys Fluent can model reactions and species transport in porous media. This includes the diffusion of species, the reaction rates, and the production or consumption of species. This is especially important in applications such as catalytic converters and fuel cells. Multiphase flow. Lastly, Ansys Fluent can simulate multiphase flow in porous media. Multiphase flow refers to the flow of multiple phases or a state of matter such as solid, liquid, and gas. This is crucial in applications such as oil and gas reservoir simulation, where both oil and gas phases are present. In conclusion, the porous medium capabilities in Ansys Fluent provide a comprehensive tool for simulating the complex behavior of fluids in porous media. These capabilities are essential in various industrial applications, from oil and gas extraction to energy production and environmental engineering. Now, let's enter the Ansys Workbench software. Okay, here we are in the Ansys Workbench software. Ansys Workbench is a comprehensive software suite for computational fluid dynamics. It includes several tools such as Design Modeler, Space Claim, Ansys Discovery, Ansys Machine, and Fluent Machine. For example, here by clicking on the geometry, hold it and dragging it into project schematic window, the geometry environment will be available for you. By right click on it, you can see the Discovery, Space Claim, and Design Modeler. The software offers advanced geometry modeling capabilities that allow users create, modify, and manage 3D models with precision. Ansys Machine, which you can find it here, and also the Fluent Machine, which is just under the Fluent, are renowned for producing high quality mesh using advanced algorithms which enables professionals to simulate complex fluid flow problems with confidence. Okay, now I want to enter the Ansys Fluent software. Here I drag it into the project schematic by right clicking on it and selecting edit. You can see the window of Fluent launcher. Our project is 3D and I want to start a parallel simulation using 12 cores of my hardware. After hitting the start, the Ansys Fluent software will be loaded. Okay, that's it. And I want to now import the um, files of the solved project by going to the files, import, and case. In the location of my file, the porous case and data, and this is my file. Here you can check the console if your file is imported successfully. Our software provides you with a wide range of mission options that are sure to impress you. These options are designed to meet your simulation requirements and enhance your overall user experience. Additionally, we offer advanced tools for checking mesh quality that are truly remarkable. With these tools, you can gain a complete understanding of your simulation's accuracy and identify potential issues before they become major problems. This gives you the freedom to concentrate on achieving the best results for your project without worrying about the accuracy of your simulation. With our top-notch mission options and quality checking tools, you're sure to experience the ultimate simulation software experience. Okay, here you can see the check option, and this is the report quality. By clicking on them, just by one click, you can check your mesh file and also report the quality of your elements. Looking to elevate your simulation to new heights, Fluent is the answer. This software is widely recognized for its exceptional meshing capabilities, but that's just the tip of the iceberg. With Fluent, you'll have a wealth of robust tools at your fingerprints for visualization, geometry, mesh, and graphical results, such as contour, vector, and streamline plots. These tools are not only incredibly user friendly and adaptable, but they also offer an exciting way to engage with your data. With Fluent, you can gain deeper insights and make more informed decisions, unlocking unparalleled outcomes. Alright, here you can see the geometry of the solution. Here's the inlet, and this boundary is the outlet boundary condition. Here, by clicking on the display mesh option, you can select and deselect each of the boundary conditions you want. For example, here I deselect the wall fluid, and now you can just see the inlet and outlet boundary condition. This is wall of the fluid, and this is the wall of the porous zone. Here inside of this wall is the porous zone. Also, another capability is the displaying of elements of the solution. Here, by enabling the edge, you can check the size of the elements all over the domain. We have an structured and high quality mesh file for our solution. Ansys Fluent is a widely recognized software that offers a broad range of versatile models to address a wide variety of physical phenomena. Here, by double clicking on the models, you can see most of the models available in the software. The software boasts an impressive suite of turbulence models, including Reynolds, average Navier-Stokes, large simulation, and direct numerical simulation. Multiphase flow simulations are enabled through the software's Eulerian, Lagrangian, volume of fluid, and mixture models. Furthermore, Ansys Fluent incorporates heat transfer models, including conduction, convection, and radiation, to provide a comprehensive solution for CFD simulations. The software also offers various combustion models here in the species section, such as finite rate eddy dissipation, partially premix, and premix to aid combustion simulations. Additionally, Ansys Fluent provides species transport and reaction models for chemical species simulations and various special models like acoustics, porous media, which is here in the cell zone conditions, and direct discrete phase model. Ansys Fluent's impressive array of features and functionalities makes it a comprehensive and reliable tool for CFD simulation. Okay, now let's go to check the porous medium options. You can close the models and go to the cell zone conditions. Here in this section, we can see all of the zones available in our project. We have two zones, which the first one is fluid and the second one is the porous zone. To display them, you can open the fluid here under the cell zone conditions, right click on them and display each of them separately. This is the fluid zone, and this is the porous zone. Okay, by double clicking on the porous, here you have some options which are the frame motion, mesh motion for the translational and rotational zones, the porous zone which is enabled, 3D fan zone, laminar zone, and also the source term and fixed values. Okay, what we have enabled is just the porous zone. So here we have the porous zone tab available. The porous zone model is used to simulate flow through porous media. The model represents the porous medium as a single continuum rather than modeling the individual pores. The effect of the porous medium on the flow is included as a momentum source term in the fluid flow equations. The source term is a function of the fluid velocity and is generally defined by the user. The porous zone can be used in any cell zone and requires the specification of the porous medium's properties such as porosity and permeability. Okay, the porous medium model is a powerful tool that offers a wide array of options to simulate and predict flow through porous media accurately. Here you can see the different options. The model allows you to specify the direction vectors, giving you the freedom to align the porous medium in any orientation. The viscous resistance and inertial resistance provide the ability to define the inverse absolute permeability and inertial resistance factors respectively to mimic the flow resistance in the porous medium. The power law model is an advanced feature that allows the simulation of nonlinear flow resistance, a common phenomenon in real-world applications. Fluid porosity is another great feature that lets you define the volume fraction of the fluid in the porous medium, which is crucial for accurate predictions. Additionally, the relative velocity viscosity option allows for the consideration of the effects of fluid properties on the flow resistance. Okay, by specifying these options, you can continue your simulation. I'm really delighted to discuss the powerful pressure velocity coupling schemes that Ansys Fluent offers. Ansys Fluent is an incredibly powerful tool for CFD simulation. It's highly represented in both academia and industry, and it's used by professionals all over the world. Fluent offers a wide range of features and capabilities. It has advanced pressure velocity coupling methods like simple C, piezo, and coupled, which provide accurate and efficient solutions for the Navier-Stokes equations. Plus, it offers a various special discretization methods. Here you can see for each of the parameters, including upwind schemes, central differential schemes, and higher order schemes, allowing for a fine-tuned balance between accuracy and computational effort. So, if you're looking to solve complex fluid dynamics problems, I highly recommend you consider using Ansys Fluent software. It's a game changer. Then we have the initialization to set the initial conditions for our solution. We have two options. The standard initialization method initializes the flow field by setting flow variables to user-specified constant values throughout the computational domain. This method is often used when you have a good estimate of the flow field. On the other hand, the hybrid initialization method initializes the flow field by interpolating values from the boundary conditions. This method is particularly useful when you do not have a good estimate of the flow field. It can provide a better starting point for the solver, especially for complex flows leading to faster convergence. Okay, now after initializing the solution, we can go to the last step, which is run calculation. Here we just need to set the number of iterations. Ansys Fluent's iterative mode is a critical process that solves complex problems step by step. It's useful for nonlinear problems, continuously refining the solution for better accuracy and control. Okay, now I want to import the data solved for this project previously, and now we can display the graphical results. Okay, after running a simulation, Fluent provides a range of options to analyze and visualize the results. You can generate contour plots, vector plots, and path lines, which help in understanding the flow patterns in a fluid. Here, if you open the results and graphics, you can see the mesh, contour, vector, pathline, and particle tracks. Fluent also allows the creation of animation, which are useful in presenting and understanding the transit behavior. Here in the animation section, you have some options. Okay, let's display some contours from the solution. The velocity magnitude in the defined plane near the walls, the velocity is 0, and after that it reaches its maximum value. We have the pressure, static pressure. Here you can see a big decreasing pressure drop, and also you have a lot of parameters like turbulent kinetic energy and also turbulent intensity. Moreover, the Ansys Fluent offers quantitative post-processing tools that include calculation of derived quantities, report definitions, and monitors. Here you can see the different options for plots. These tools allow users to extract specific data of interest, such as forces on a body, average temperature in a region, or flow rate through a boundary. Here, if you open the report, you can find all of them. Fluxes, options related to discrete phase model, forces, projected areas, and the important surface and volume integrals. Fluent's post-processing capabilities are highly customizable, allowing users to tailor the output to their specific needs. Overall, Ansys Fluent's post-processing capabilities are essential in interpreting the results of CFD simulations, enabling users to gain insights into their simulations and make informal design decisions. Remember, the best way to learn about these capabilities is to use the software and explore its features. Now, I want to show you some results extracted from this software.